so our next and final speaker, thanks Kathy, is the NOAA lead of a local NOAA ASPB group, Jeff Key, and in addition to being a great NOAA employee, he's also an expert in the cryosphere. So he's going to talk to us about the sum of the parts. With the lights.
Which in itself is not very informative. But the idea here, this is a bit risky to do this because it's not a science talk, so I'll admit that right from the start. But if you all get up and leave, I'm watching. So some of you have been involved or are currently involved in activities that coordinate observations at some level. For example, AMRC is heavily involved in the automatic weather stations around Antarctica and works with other countries. I don't know how formal of an arrangement that is, but it's a coordination activity. Some of you have been involved, at least on the periphery of CGMS, the Coordination Group for Meteorological Satellites, perhaps only in terms of contributing papers or parts of papers that go through NOAA to CGMS. But this is another form of coordination of activities. Well, I've also been involved in one, a very formal one, that I'll tell you about. It's called the Global Cryosphere Watch of the World Meteorological Organization. But I talk about this program so much that I didn't want to only talk about it. So this is where it's getting a little risky, because what I want to talk about is the whole idea of international coordination activities and the different levels of activities, and whether or not these are productive. So we'll see how that goes, and I'll explain this sum of the parts in a minute. So I'll jump to the conclusion, which I'm stating as a thesis, that integration and coordination of observing systems, and this could be surface-based, aircraft, or satellite. Of course, we're mostly interested in satellite here, but I'll be talking a lot about in situ as well. Integration and coordination of observing system components can, in fact, be beneficial. Okay, a lot of this you're going to say, well, no, I do that. But that's okay. But only to a point. And that's the part where a lot of you haven't experienced that yet, but many will, especially the younger scientists. Will get involved, will ask to be involved in GEO, for example, the Group on Earth Observations, and GEOS, the Global Earth Observation System of Systems. Keep that in your mind. System of systems. The absurdity of that. Anyway, so here is something just for really for the cryosphere, and it's an acronym soup. I realize that I didn't make this, but interestingly, the person that did make it is a GEO person, and he made this in a positive way. I'm using it quite the opposite. If he knew that, of course, he'd be very happy. So I'm asking the question, and I'll come back to this and explain a little bit more, but I'm asking the question, if we're coordinating observations of snow and ice, have we gone a little bit overboard with all of these different groups? And the Global Cryosphere Watch, by the way, is right here. Now, again, I'll explain a little more about these layers of coordination. But have we gone too far here? Are we really adding value? That's what I want to talk about. Well, let's start with something that Aristotle said a long, long time ago. And what he said was this. Well, I have no idea what he meant. It's all Greek to me. So I translated it, and lo and behold, it was actually something very useful. It wasn't, I want to order an omelet. It was that the whole is greater than the sum of the parts. Well, you've heard that before, right? And Aristotle wasn't the only one to put forth this idea, but he was perhaps one of the first. Well, that's what I want to talk about. And in fact, the title of my talk is the last part of this part. More recently, there's a field of study called emergence, or a study of the concept of emergence, and similarly of complex systems. And they both say the same kind of thing that Aristotle said, but in different words. That in fact, a system can have qualities that you can't trace back to the individual components, that something happens when you put together the components of the system, and the whole becomes greater than the sum of the parts. Well, there's some math behind that, but it's too complicated. So, and that's not to imply that I understand it and you wouldn't. I have no idea what this is about. So we're going to just go on to something simpler. But I had to put in an equation. It's an equation anyway. And you'll see this in 3 different forms. And it's very simple, but it's just something graphical here, where we say we have some parts. And let's say these P's are different observing stations, or different satellites, individuals. And you measure something, but you get some benefit out of it. I'm calling that benefit now, for no particularly good reason. And then E, I'm using as the whole. Well, if these are completely independent, then it makes sense that if you add up these benefits, they're independent, that the sum of the benefits is the sum of the individual parts. It's not what Aristotle said, because this is all independent. On the other hand, if you somehow connect together these individual components, and perhaps provide some forcing. And forcing is really a terrible word here, because, well, you'll see why later, but this really means you do something that changes the way these individual components operate, and you therefore get some additional benefit, which I'm calling beta, which is a function of the forcing. So beta of that. Well, now, and I'm not proving anything here, I'm just illustrating. Now you say, now we have a new emergence, E prime, that's the sum of not just the individual benefits, the independent benefits, but this added thing here, and obviously that sum, assuming that beta is always positive, which it is by definition in this case, is greater than the sum of the parts. So the whole now is greater than the sum of the parts. Okay, I know that's elementary, but it works. Good graphical illustration. Okay, now let's go back to reality. What does this have to do with observation? Well, we have lots of individual stations. Here's a Russian drifting station from so long ago that there wasn't even color film, which some of you probably don't even know what film is. That was something that went in a camera. Anyway, and here's a more modern one that still wasn't film, but it was at least color. This is in Northern Finland. Okay, lots of individual stations, but they're all, well, just for the sake of illustration, they're operating independently. Similarly, we have individual satellites that, for the most part, are independent, although we have these groups like CGMS and CIOS, the Committee on Earth Observation Satellite, that are trying to coordinate things. But, again, for the sake of argument, let's call these independent, and therefore, if we add together their benefits, it's just, the whole is not greater than the sum of the parts. Some of the challenges with having individual surface-based stations or satellite systems is that they vary in ownership, different countries, different parts of the same country, government versus university versus whatever. And that creates quite a challenge if you're trying to do climate research and use all of these different observations in a consistent way. That's why people want to coordinate things. This is just an example from China. So this is true for both in situ and for satellite systems. We have all these different satellite systems, and is anybody thinking about how they work together? Yes, people are thinking about it, and that's what we're talking about here. So back to that forcing function, or the forcing, something that changes all of the individual components of the observation system. What are those things that can change the observations such that the sum of all of them is greater, the whole is greater than the sum of the individual independent ones? Well, these are the kinds of things that we're trying to do in the global cryosphere launch. Things that will create added benefit. For example, measurement standards. You want to make sure they're all measuring things in the same way. Makes perfect sense. You do that, you have much more usable data. Observational requirements, user requirements, maturity assessments. We have lots of different satellite products, even for a single geophysical parameter like CS concentration. We don't need to change them. We just need to know where they work, where they don't work, how mature they are, and so forth. That improves the usability. of those products. At surface-based stations, we wanted to make sure they're measuring some core set of snow parameters, for example, or CS. Data standards, interoperability increases the usage. Coordination with other user systems, and then when you get really high level to the GEO, group on Earth observations level, then you're trying to get countries to work together, provide funding, and improve the sustainability or create sustainability observations. Okay, a very basic level of coordination, an example of one is this International Arctic Systems for Observing the Atmosphere, where they've taken existing stations, some are NOAA, some are Environment Canada, some are Roshydromet, Russia, anyway, Finland, Finnish Met Institute, and they're trying to coordinate the observations in these. And these happen to all be GAW, Global Atmosphere-Watch stations, and they're probably going to become Global Cryosphere-Watch stations as well. An example from the satellite world of some basic level of coordination is a virtual constellation. In this case, this is an illustration of a virtual satellite constellation for sea surface temperature, where they're just saying, okay, we've got sea surface temperature from all of these different satellites. Let's compare them, let's assess them, let's do whatever we do in a virtual constellation. There was an effort that went on for 10 years called the Integrated Global Observing Strategy, whose goal was to assess the observational capabilities and requirements, the state of the observing system for things like, this is terrible, it's a low resolution graphic, so I think it's trying to be, let's say carbon theme, and then there was a water cycle, and actually there was coastal and geohazards, and ultimately there was land, and then there was also a cryosphere theme, which I led this one. This took about 3 years to come up with this nice report of the current state of the snow and ice observances, observational requirements, capabilities, and so forth. That led to, finally, I'm getting to the Global Cryosphere Watch. This is a World Meteorological Organization, WMO, program approved as of middle of 2011, so we're really just getting going, gearing up, and things are going quite well. And our goal is to provide authoritative, clear, useful data. It sounds like a lot of hand-waving. I don't even know how to read this because it's so broad, but it's all true. The idea is that we are trying to coordinate the snow and ice observing system. And for the cryosphere, that's very complex because it's not, unlike the atmosphere where it exists everywhere. And so if the way you measure ozone, for example, is the same here as in many other places with minor differences. In the cryosphere, you have sea ice, which is in one spot. You have land ice, glaciers, ice sheets, and ice caps. Totally different game. Snow cover, permafrost, for crying out loud. Where the heck is that? It's down there in the ground. It's ice in the ground. Completely different set of people, coordination mechanisms, measurement methods, all that. So anyway, this is it's a big thing to try and do this, to try and coordinate it. But what we're trying to do is all those things that I had in that list about measurement standards, product assessments, and data interoperability, and so forth. All of that is useful. We're not trying to, except perhaps for measurement standards, really change what people are doing. We're trying to get people to work with us, so we all work together and come up with more useful data than there was before. Oh, I guess I just said the next few slides. So we are working. WMO has had its technical regulations, which really is measurement practices and standards, for many years. You can see this is dated in 1988, and we're now contributing to that, and we'll be helping revise that. It's going on, just started a couple months ago. We've sponsored some product intercomparison workshops, snow cover, sea ice, and so forth. That will continue. That's very important. That's what's illustrated down here. Maturity assessments, all that's important for the user because I think we've really been lacking in that. I mean, all of us, that we're not good enough about, although Andy talked about the GWEX Cloud Climatology workshops. That's excellent. That's leading towards the self-assessments of maturity and product comparison. It's a very important thing to do for users of your data. We're doing less with integrating across observing systems, but there's a little bit of that, particularly in terms of satellite and surface. Most of the satellite here, not the surface, where we're getting something called the Polar Space Task Group to help define where and what, not so much where, but what should be measured at the surface for validation of cryosphere products from satellite. So that's very good. We got satellite people talking to surface people while we establish in the Global Cryosphere Watch our surface network, which we call CryoNet. Very clever. Okay, and then we have people at the Meteorological Institute of Norway, METNO, down here, have created a data portal or data catalog for us, and they're working very hard on interoperability with the National Snow and Ice Data Center, with the WNOA information system, with the Canadian Cryosphere Information Network, and so forth, so that data that are housed in these different places are easily accessible through the Global Cryosphere Watch data catalog. And that's, like I say, hosted in Oslo. We host our information website here at SSCC, and Bill Bellin helped along with this. And it's a very dynamic website. If you haven't checked it out yet, and it's still growing. And we only made it live in the middle of late February, early March. And so it's here. Well, it's a mouthful, but it's easy. globalcryospherewatch.org. And it's got dynamic data that's 1, 2, 3 days old on various aspects of the cryosphere, which we call Cryosphere Now. That's down here. A live news feed from a whole variety of sources. Lots of good stuff there. Okay, now back to this, layers of coordination. So closest to the Earth here in this inner circle is where our individual observing components would be. Surface stations, satellites, and so forth. Obviously, we want that. We wouldn't have anything without it. If you go out into this next ring here, then you get to things like the Global Cryosphere Watch. And I hope I've convinced you that there's some utility to coordination and integration at that level. And there are others. I don't think I have CGMS on here. Again, I didn't make this. Well, CIMSS is here, Committee on Earth Observation Satellites. They're space agencies talking to each other, saying, what do we need? Let's think forward to the satellite observances. Okay, that's useful. I'll give them that. This is what then there are a lot of Arctic groups. This is a World Climate Research Program called Climate and Cryosphere. And there is a World Climate Research Program, SCARS, the Scientific Committee on Antarctic Research. This I'm a vice chair of. It's WMO Polar Space Task Group. And in fact, here is WMO there, and so forth. But now we got this outer ring here. And geez, I really hope that none of you are intimately involved in these groups, because I'm about to insult you. I'm sorry. This is a group, okay, GEO. GEO, this idea really came from the former head of NOAA, or at least he was one of the main motivators of it. It's a group on Earth observations, and this is their framework called the Global Earth Observation System of Systems. Well, again, why does he do that? But anyway, it's a good idea and concept because it brings together lots of countries. And the whole idea was, let's bring in countries and let's free up some funding to improve the global Earth observation system. But because there are already systems observing the Earth, we better coordinate those so we have a system of systems. It's not a bad idea. It's not doing much, but it's not a bad idea, and it's still there. And anyways, this one's even worse. It's called the Sustaining Arctic Observing Network, SAHI. It's part of the Arctic Council. You probably can't read that. And they don't actually do anything. And I'm going to leave it at that. So here is my Siskel and Ebert and Roper assessment. And I give a thumbs up to the inner circle, the actual observation, the components. A thumbs up to some level of coordination, and a big thumbs down to anything we got. Maybe I don't know. But this is the system of systems thing where I'm saying, okay, Global Cryosphere Watch has a system. This is a Southern Ocean observing system, and there are I lost my train of thought. Okay, GAW, Global Atmosphere Watch, and there are all of these different groups coordinating various things. So then in comes GEO or SAON and says, we better coordinate the coordinators. And maybe they're trying to get them to talk together, but maybe not. But the point here is that there's less of a forcing function at that level. You've already done within each of these the measurement standards and best practices, the interoperability, the product assessments, the maturity, all of that. What more can you add here? There's a little bit, but there's not much. So now when you start summing up the sums, the E primes from before, here, then I didn't know if there was actually a mathematical symbol for not significantly greater. I just put the sort of the computer not. And anyway, I'm saying that this system of systems, that whole is not significantly greater than what we had before. And you don't have to agree with me. This is an editorial. I can say whatever I want. And there won't be time for questions. So if we looked at that benefit, then there would be any number of primes, including 0 up here. That's the red curve. Where you against the level of coordination. You improve the benefit significantly with some coordination. If everybody's taking measurements the same way, that's a great thing. You've got a much better product. But then it starts to level off here. And I know I don't have this curve. This is the forcing, which the amount that you try and add to increase that benefit goes up quickly, and then you don't add much anymore. And I know this isn't quite in the right spot. I was trying to piece together. So this part of it, some level of coordination is very good. If you go too far, you're just not adding. So another way to look at it is that this is back to the original picture I showed. You can see all the little parts here, right? But when you put them together in the right way, you get something where the whole is greater than the sum of the part. Now I took this picture and thousands of times used it to create this. Well, it's the same picture. It's a little different, but it's not significantly better. So some coordination is good, excessive coordination, not good. Thanks.
Well, unlike his statement, we have questions coming. So, Paul?
Jeff, could you go back to your last slide?
Sure.
Thank.
So, these various WMO reports, so that's your picture right there. I don't see it really as refining that particular space. How about there's one person and another person, and it's not refining your space that you're occupying. It's adding the other crop. There's not one person.
Yeah.
It's an Earth system, and the atmosphere interacts with the cryosphere.
Yeah.
So why doesn't various organizations interact?
Yeah, well, that's an excellent point, which is not captured here. I don't know why they don't interact more.
Because there isn't this coordination at that level.
Yeah. So that certainly is good, and at that level there are things to add. I think it gets harder.
It does.
And you get people that are happy doing what they want to do, and that's fine. But to get them to talk, yeah, we all know that is difficult. But you're right, that's a good point.
You have done, I like your analogy that you've done the majority of the work.
Yeah.
But there's still there's a number of different organizations that are thematic organizations that have done that work. But you haven't put that picture with the other one together.
That's very good. You're right. And I was a little bit harsh on Geo, and I'm sorry.
I'm going to defend you because what you're talking about really is atmosphere, ice,
So if
land,
you go back to
ocean,
those IGOS
different
reports, there's an IGOS report for all the components of the Earth system, and they have not been tied together.
No, they haven't. And actually, back to IGOS, I didn't say this, but all those IGOS themes were supposed to transition into GEO back in 2008 when the IGOS partnership was dissolved. Sadly, because it was a bunch of science people doing great assessments of the observing system, but with no clout to get anything done, to get their recommendations implemented. So they said, so they agreed with GEO that they would transition into GEO, and then for the most part, nothing happened. And why? And that's one thing. What you're suggesting is one thing, the type of thing that would have happened, but it just hasn't yet.
And it needs the, you mentioned GEO was, it was a NOAA administrator that was charging that forward. And then NOAA is invested. And as soon as that changed. So we have all these things bubbling up, but there, to me, there seems to be it is coordinating all these other coordinating activities.
It is. And you get a lot of people, including us, the Global Cryo, we've been asked to be part of GEO. They have a GEO Cold Regions Initiative. I've been asked to lead that. Or it's suggested that I could lead it. But I asked the GEO people, why? What do we get out of it? And until they can tell us what benefit there is, not just to me, but how is this going to improve observation in the cryosphere? I'm reluctant to do it because it just means they want us to write reports, and then they want to report that what we're doing is toward the GEO. Now that's a very sour kind of attitude. That's the kind of guy I am. But I think there could be something there, and you believe there could be something.
I think that it will not improve how Cryosphere is done, but it might integrate Cryosphere with the rest of your system.
Well, is there a question?
Yeah, I don't know if it's a question. I happen to be at a GEO meeting. I'm not a GEO guy. I have to say reluctance to see too many symptoms of dying. But I noticed one thing is there were a lot of large animals, I would say, there. Big, important people.
Yeah.
So that was one of the things that GEO always impressed me with. They were able to get secretaries of state, whatever, so you had high-level recognition. Sometimes spare change would fall in their pocket. Fun things. Not that often. But this was the 5th or 6th year of GEO, and they were asked to do a self-assessment. All right, so these very important people were sitting up in front, and their assessment of themselves was they didn't succeed in everything they tried, but the one thing where they did succeed was more data exchange. So I thought, well, that's pretty good. Is that true?
I think it might be. I haven't experienced that, but they have GeoNetcast, which I think is functional. I couldn't tell you exactly what it does, and a lot of it might be more for developing countries that have benefited more than anybody. I'm not sure about that.
Now, one of the points they made was the data from the developing countries was getting out into the
Okay.
rest of the world. I don't know.
I don't think they're lying.
It seemed like an awful lot of people had lined up there to say that they were being credited for the one data source they're getting deep in Africa.
That's probably true.
Yeah.
Yeah, and they the Secretariat, and that's an important function, has a new director now,
Barbara Ryan.
and I think she'll be better than the previous one.
It'd be hard not to.
Yeah, that's true. Barbara Ryan, for those who don't know, she was originally she's American. Was USGS retired, but then led the WMO space program for a while, over Florida. And then now is the head of the GEO Secretariat, which happens to be in the same building. It's in the WMO headquarters in Geneva, but she's very good. And I hope it goes better, because there is a lot of yeah, you're right. There are a lot of high-level people that go to geoplenary meetings. I mean, you can't just go as just a scientist. You know it. But if you get a place at the table, it's very formal. So like a UN. But what's important is what's happening at the lower levels. You don't see much of it. But I've also heard what you said on the data exchange, being improved, being a big accomplishment. They need more than that. They need to start freeing up some money.
Any other questions or comments? To what degree does that, some of the parts depend on the people involved?
Yeah, tremendous, I think. Implementing those, doing those things that add the value. And we're experiencing that now. We've had tremendous, when we have a workshop, like our CryoNet, the Surface Observation Network for Global Cryosphere Watch, we had our CryoNet workshop in last November. Great turnout. People, a lot of energy, very willing to do all this. But you have to count on that energy and momentum carrying forward because they all have regular jobs and they all need to just go out there and measure snow or whatever they're measuring. And to then get involved in assessing, trying to select the right measurement standards that not only they will implement but others will, it takes a lot of energy. And it takes people that they work for going along. Even me, for the Global Cryosphere Watch, I could spend a whole lot more time on it, but it's not, doing my JPSS work or everything else that I do.
Who was coordinating the Cryosphere data gathering 20 years ago? CIMO?
No, CIMO is part of it, but I mean, there are other groups, the data gathering. No, I think it's more on this national level. Although there was 20 years ago, I don't know if there's a permafrost network, but I don't know if that existed 20 years ago. So no, I think the Russians are out on the ice measuring, on the drifting stations, measuring sea ice, and then you have the permafrost people digging holes, drilling holes in the ground, and so on. And really not a lot of coordination. Even if you look in the WMO technical regulations on measurement standards, they're just not there. And in fact, we started doing the IGOS Cryosphere theme because there was almost no coordination. The Global Climate Observing System had some requirements for snow and ice, and then the oceans people had something, and the land people had something different, and it was all just kind of falling through the cracks. So we took the bull by the horns and said we need to bring some attention to the cryosphere because, my God, it's the most important component of the climate system.
It's going away.
All right.
Yeah, it won't be there.
All right, well, let's give a round of thanks again for